Hi everyone, in this video I'm going to teach you how to get every mark out of the calculation questions in your two physics exam papers. Now in 2022 you're in a unique position. You get given all the equations on the equation sheet, but I just want to make a quick point before I start teaching you how to do the questions. This equation sheet is going to make it so much easier for you, but you still have to know how to pick the correct equation. If I scroll down, imagine a question where I'm asked to work out the power. Well, if you just look, there's one equation that has power in it, another one. That one has two lots of power in it. There's another one at the bottom, and another one, and another one. That's like 5 or 6 equations, all which have power in them. I need to be able to pick which one to use. Now, in any physics calculation question, just like in a maths exam, you get marks for your working out. So on the screen, you can see you get marks for converting numbers into the correct units, if you need to. You definitely get marks for putting numbers into a correct equation. You get marks for changing the subject of the equation, if you need to. You get obviously marks for calculating the answer, marks for putting units on your answer if they haven't, and marks for the correct number of significant figures if they ask you to do that. Now, if you forget one of those steps, let's say you forget to convert the number to the correct units before you start, you can still get marks for every other step, but only if you show every other step. So you must show you're working out. You can't just write an answer. So let me show you what I mean, and let me show you the steps you need to take. So this is just a question I've picked. I think it was in the 2019 or 2018 exam. So the diagram shows a tennis ball thrown vertically in the air. So if I zoom out a little bit, you'll be able to see the whole diagram. Too much. So there's the full diagram. You can see them throwing it. It's got different positions. And then the calculation question is, at position C, the ball has just left the tennis player's hand at a speed of 5 meters per second. The tennis ball has a mass of 0.058 kilograms. Calculate the kinetic energy. So it's very clear what I'm supposed to calculate. I'm supposed to find the kinetic energy. But I've also been given mass and I've been given speed. So on the equation sheet, I need to find an equation that links those three things. So if I switch back to the equation sheet, oh, there we go. It's the first one. It's got kinetic energy, mass, and speed, all three things that were in the question. So I'm not looking for an equation with one thing. I'm looking for an equation with three things. So the first thing I would do to help me get the marks is write that equation. I would copy it from the equation sheet, and I'd copy it in letters just so it's quicker for me. Now, I said I get marks for converting things to the correct units. These are already in the correct units, so I don't have to do that. The next thing I get marks for is putting numbers into an equation. So that's what I'm going to do. Kinetic energy is the thing I'm looking for, so I'm just going to leave that as EK. A half is a half. Times, but now I'm going to put the mass in, 0.058. And then I'm going to put the velocity in, 5.0. And it says squared, so I'll put the squared back in. As soon as I do that, I've gained a mark because I've put numbers into a correct equation. Then the second mark is for calculating my answer. So I would type all that into my calculator, no need to do it in my head, and my calculator is going to pop out 0.725. Done, 2 marks. 1 mark for putting the numbers into a correct equation, 1 mark for calculating the answer. So let's have a look at another one. So at position B, the tennis ball has 0.38 joules of gravitational energy. Calculate the height of the tennis ball above the tennis player's hand when at position B, and we're given gravitational field strength. So I'm given gravitational potential energy. I'm asked for height, and I've got gravitational field strength. So I need an equation that connects those things. So again, if I just switch to the equation sheet, so gravitational potential energy, gravitational field strength, like the third one. gravitational energy, gravitational field strength, height. It's got mass in. I didn't mention mass. But if I remember earlier in the question, I was given the mass of the tennis ball, and it's the same tennis ball. So I do have everything I need. So we've found the equation. So next step, write it down. So gravitational energy equals mass times gravitational field strength times height. The next step, remember, is I put the numbers in. So I'm given the gravitational potential energy, so that's 0.38 equals the mass I was given before as 0.058. Just had to check. 0.058. I'm given gravitational field strength, so times 9.8. And I'm then asked for height. I don't have that number yet. Now, the next step I would do, which I'm actually going to grab my calculator for, is I'm going to simplify this equation. I'm going to leave that as 0.38. But you know what? 0.058 and 9.1 are next to each other. I may as well just work that bit out. So if I do 0.058 times 9.8, I get on my calculator 0.5684, and I've still got my times height. By timesing those two things together, I've now got less to worry about in my equation. I've still now just got two numbers and the thing I'm missing. Now this one I do have to rearrange. I need to make h the subject. At the moment, h is times by 0.5684. So how do I get rid of times 0.5684? You get rid of a times by dividing. So it's going to become 0.38 divide 0.5684, and that's going to give me height. So if I type that bit into my calculator, I get 0.66854, and the calculator keeps going. I don't really need that many numbers. I'll just do two significant figures, 0.67. If you did write the whole thing, you'd still get the mark, though, because it doesn't ask about significant figures. But I got marks for that the moment I wrote that second line, because I'd put numbers into a correct equation. I then got marks for this bit for rearranging, and then I got a mark for my final answer. Let's keep going. Let's do another one. So, a small aircraft accelerated down a runway at 4 meters per second, meters per second squared. So, I'm given acceleration. That's the acceleration I'm given. It started from rest. So, that means it started with a speed of 0. And then I'm given that it reached a speed of 34. And I'm asked to calculate the distance. So I've got acceleration, I've got two speeds, and I want distance. So if I go back to my equation sheet, and I know where this one is, but you'd have to browse through. This equation has got two speeds, final and initial, but notice it calls them velocity, not speed. So I've got to be careful. I've got to know that for this, they mean the same thing. And it's got acceleration and distance. So this is the equation I'm going to write down on my page. So the equation I found was v squared minus u squared equals 2 times a times s. Now, it's a bit weird. I mean, v and u, but remember on the equation sheet, it did tell me what they were in words. It seems a bit strange to have distance as s, but the equation sheet did tell me s was distance, so I'm just going to go with what they've said. But I'm going to start by putting the numbers in that I've got. So v, the equation sheet said, was final speed. Well, that's 34, so 34 squared minus initial speed. Well, it was stopped, so 0 squared equals 2 times the acceleration, which is 4, times distance, which for some reason they've put as an s. Now, that's really hard to change the subject of if I leave it as all these separate numbers, but there's no reason why I can't work out bits of it as I go. 34 squared, if I type into my calculator, is 1,156. minus 0 squared, well, minus 0 is the same. 2 times 4 is 8. So just by doing the separate bits of the equation, I've just simplified my equation. Now it's like an equation I'm used to, with just two numbers and a letter. At the moment, it's 8 times s. I want to make s the subject, so I'm going to get rid of the times 8 by dividing by 8. So it becomes 1,156 divided by 8 equals s, which is my distance. And then if I type all that in, I get 144.5. Now, if I put that on the answer line, I mean, I've got 1 mark for putting the numbers in. I've got a mark for rearranging. I've got a mark for working out an answer. But it did say give your answer to 2 significant figures. Well, 2 significant figures. The first number is 1. The second significant figure is 4. And the number after it is below 5. So I'm going to round down rather than up. So that's 140. And that's the last mark put as the right significant figures. But even if I miss a step somewhere, I can still get the other marks. Let's do another one. Now, this one looks a bit different. They've given me numbers in a table, but it's no different. I'm being asked to calculate x. If I look at the table, x is useful power output. I'm given an efficiency, and I'm given a total power input. So I need an equation that links those three things. So if I switch to my equation sheet, so I need efficiency, input power, and output. There we go. Efficiency equals useful power output divided by total power input. So that's the one I'm going to use. Now, I'm not going to write all that in full. I'll write F for efficiency equals power out over power in. So I've simplified it because there was no letters. Now I'm going to put my numbers in. Now I'm working for this last row, aren't I, to find x. So I've got efficiency, 0.3. So 0.30 equals, I've got power input, which is the bottom. So I need the top as power output. That's what I'm looking for. And then total power input is 9. So I've got a mark for putting the numbers into the equation, even if I've not rearranged it. But I need to make power out the subject. At the moment, power out is divided by 9. So I'm going to times by 9 to get rid of it. And I'm going to go up here to do that because I'm running out of space. So it's going to become 0.30 times 9 equals my power out. So 0.3 times 9, 2.7, I think. Let me check. Yep, 2.7. So that equals 2.7. I'll write that on the answer line. So I've got a mark for putting my numbers in, a mark for rearranging, and a mark for the answer. 3 marks.